My background, I was trained as an architect. I have both a bachelor's and a master's degree in architecture, and I have spent the last 20 years exclusively focused on sustainable building. So I was very involved in LEED in the early days. I chaired their Materials and Resources Technical Advisory Group for many years. I've chaired it for a couple of years, served on the group for many more than that. Also chaired the development of LEED for Homes and its materials group as well, simultaneously. Also served on the LEED steering committee overall for the U.S. Green Building Council for many years. So I'm deeply steeped in the whole LEED culture, and also I'd say I'm somewhat of a futurist, so I'm always interested in what's coming next and how can we move things along faster, change things faster, because I think the world is experiencing so many challenges that we need to do more, better, faster, all the time. So I'm always looking for the next bigger lever. What can I pull on here and make things change more? So, and you're probably very aware of this, the Brundtland Commission definition of sustainable development, which really sort of drives our approach to sustainable building. So we want our buildings to support this future of sustainable development, which will enable us to provide a good life for the future generations as well as our own. So that's at the core. And we approach this on a number of different levels. So I think at the highest level of what are our goals, and we want to improve the health, the well-being of our global community, really at all levels. And sustainable building has the opportunity to do that. And of course, we tend to work at it mostly at the local level, but there are many, many sustainable building efforts that are looking at larger scales as well, beyond the individual building or landscape, and looking at entire community fabrics and regional infrastructure and so forth. So the scope of opportunity in sustainable building is very, very broad. And again, mostly when we think sustainable building, we think about a building. But these, we can address whole communities. We are now seeing, for example, there's a town in Texas. There's another funny line that you can end that with, but I'll leave it off. It has to do with a former US president. But there's a town in Texas that is being developed, the whole community to be zero net energy, for example, and with all electric vehicles. So no longer about a single building. And in terms of infrastructure, we're looking at much smarter ways to build our transit systems, our water conveyance systems, and the way we even think about water conveyance. We're looking at distributed generation for power as a supplement to centralized generation of power. Obviously, this is what photovoltaics are about, solar rooftops. And that's the way we provide services. So we've tended in the past to think of services being provided exclusively by large centralized industries and organizations for our power and water and sewage conveyance and so forth. Now we're starting to understand that many of those services are actually more efficiently and more ecologically provided at a more localized level. And then of course landscapes as well as the buildings within them. This particular image I like because it sort of represents many of the items on this slide. This is actually a living wall that is installed in the lobby of a brand new building that's a few blocks from here. And so it's a piece of art. It brings nature into the indoors. It helps moderate the interior environment by the transpiration of the plants, and it provides an interior landscape. It is a plant community. It's not a monoculture. It's diverse, it has many different types of plants in it, and it's providing a service of cleaning the air within that building. So it's really pretty amazing. We have some wonderful examples like that around here. Moving on to the objectives of sustainable building, we have also many opportunities across all phases of life cycles of the built environment. So again, we tend to think sustainable building, we think about the construction, but there's also the operation of the building, how it's maintained and repaired over time, whether it requires a major renovation, eventually may need to be replaced, and if so, we're removing something. What are we doing with what we're removing? And so we try to think about all of those life cycle phases as we even begin to design a project. So we're envisioning what's happening through all those stages of its life. How will it be maintained? What are the substances that will be involved in maintaining it? Can it be maintained, for example, with non-toxic substances that don't have to be transported halfway around the world or don't become a waste burden? So, and when we remove a building at the end of its lifespan, how do we remove it? And are the materials that are embedded within it usable again? Or do we just throw them away? So we want to be thinking about all of those things. So how does this translate into action? We have I would say, most traditional categories for thinking about green building actions fall within these categories. Land or otherwise site or landscape. You know, you may hear about it in LEED, of course, it's sustainable sites. The goal is our, sort of earthly foundation. And there are many, many actions, of course, and I've just given one or two examples for each of these up here. So again, we're interested in protecting the topsoil, which provides nutrients for the things that we grow, also processes waste. Soil is a waste processor, and we need to preserve habitats. Energy, and of course, you just heard from Robert about a number of strategies just in this building. Lighting technologies, we have daylighting technologies, and we have shutters that moderate our use of daylight, and we have effective heating and cooling strategies. There are many building enclosure strategies as well. Do we make buildings more airtight or more air permeable? It's probably a very different solution in Thailand, where you have a warm, humid climate, than it is, for example, in our California desert, where it's very hot and very dry. So, or up in the mountains here to the northeast, where it can be very, very cold too. So interestingly enough, by the way, I don't know if you know this, but California has 16 climate zones that are quite distinct. And it's particularly humorous because the whole country of the United States is usually characterized as having 6 or maybe 8 climate zones, but we have 16 just in one state. So it depends on how granular you get, of course. We can break down those 16 even more into microclimates, and sustainable building design takes into account the climate and the microclimate in which the project occurs. So we have to be very plugged into the appropriate solutions for the particular location, and rather than using rules of thumb, which can be very misleading. So water, very, very important issue for us in California right now, as we are in the middle of a drought. The most severe drought we've had in probably a half century or more, certainly within my living memory. And we tend to be drought conscious in California because we go through cycles of drought, but in between we have a tendency to forget, and we get lazy again, and we have to be reminded, oh, right, we live in a drought-prone area. But worldwide, we have, in a sense, a freshwater shortage because many, many people on the planet do not have adequate fresh potable water. And so the way we manage water and wastewater is tremendously important. So it's not just about conserving water, but how do we deal with it? How do we treat it? Our gray water and our black water, and making better use of the water resources that we have. We have, for many years, treated what's called stormwater as a nuisance, as something that needs to be gotten rid of. Oh, stormwater, put it in pipes, make it go away. Well, we now understand that this is a bit wrong-headed thinking, that the rain that falls on the earth is a gift, and it is meant to percolate into the soil, to keep the soil microorganisms healthy, which help them do their job of, again, processing waste and creating plant life, which is really important, recharging the water table. And so when we put it in hard surfaces that go into hard pipes and take it away, we're creating a terrible disruption to our hydrologic cycle. So we're trying to correct that now whenever possible with sustainable building projects. And then materials, of course. And materials are very interesting because they're often the first thing that interests people about sustainable building. They want to know, well, what is this? You know, what is this? What makes this green? So the carpet might be recycled content. The paints might be low in volatile organic compounds. The wood might come from a sustainably managed forest. These are all really important qualities. And we're starting to understand more recently that it's even more important than we thought. For many years, we were told that the embodied energy or the impacts of the materials were really a small fraction of the impacts of a building overall, that most of the impact occurred in the operation of the building through its life cycle. Well, we now understand that that is true. The materials themselves may represent 10 or 20 or 25% of the impacts. However, they occur all at the very beginning of the building's life cycle. And we know that from a climate change perspective, our next 20 years are absolutely critical in reducing carbon emissions for the world. And so we need to be really, really careful to reduce the carbon impacts in our new construction as much as possible, you know, not just thinking about the operation of the building, but in terms of what we put into the building, and to try to preserve and rehabilitate as much of our existing building stock as possible and make use of that and not sweep it away for the new. Because, you know, in America, we've been very enamored of the new, and we now understand that not valuing the heritage of the past and the embodied values of the materials in those older structures was a mistake. So we're starting to understand this more and reflect it in more of our projects. There are often concerns about the sustainable materials being more expensive or having some risk attached to them. But the reality is there are many, many sustainable materials that are not more expensive and are absolutely proven. You know, ironically, some of our oldest, most traditional materials are greener. You know, again, wood, provided it comes from a well-managed forest, of course, and is not implicated in clear-cutting of critical ecosystems, is a wonderful material. And in fact, one of the really interesting things that we've seen in structural materials in the last few years is increasing use of what's called cross-laminated timber to create taller and taller structures. So it used to be thought, well, if we're going to build tall buildings, we have to use steel and concrete. Well, we now know that we can use wood, cross-laminated timber, to go up pretty tall, 12, 15 stories. And honestly, from a sustainability perspective, if we balance all, impacts of vehicular traffic and sort of density considerations, that is about an ideal density for a city, is 12 to 15 stories. Taller than that, and we start to have more challenges of supporting those really, really high-rise cities. So there's some really interesting developments in that area. There are new materials that are being developed all the time, but I believe, and my colleagues who are at the forefront of the sustainable building movement generally believe that we don't necessarily need the most advanced, the newest, most technological materials to create the most sustainable buildings. So it's always good to take a critical eye to a new product. And in fact, often products that are claimed as sustainable or green, once you start asking those critical questions, you find out that those claims don't necessarily even have much behind them. So if you ever see a product and you wonder why is it more expensive? How long will it last? Is this going to create a maintenance or a durability problem? Ask those hard questions and make the product manufacturers tell you the answers. And if they give you an answer like, oh, that's proprietary, just say no. Because one of the things I will get to towards the end is another trend we are dealing with is towards more transparency, because we're starting to understand that transparency is critical. We cannot make good decisions about materials if we don't have good information about what those materials are and how they perform. A little bit about the benefits of sustainable building. Of course, the focus of many of my comments so far is they reduce environmental impacts. And these are just a few statistics created by the U.S. Green Building Council on building impacts in our country. And I imagine the numbers are a little bit different from place to place around the world, but they're not small numbers. I'm willing to bet almost anywhere where there's a significant amount of development these days. So of all U.S. electricity consumption, 71% attributable to buildings. Of all waste output, 65% come from buildings. All carbon emissions, 39% from buildings. And water use, 12% from buildings. Water is still not insignificant, but of course the biggest water users are agriculture and industrial processes. Industrial processes are a very big factor with water use. Nevertheless, lots of opportunity for us to do much, much better in all of these categories. So equally important, and really in terms of going back to Thailand and talking to other people about sustainable building, the thing that people tend to get most excited about is health, because health affects all of us, our families, and so this matters. I heard a statistic the other day that said something like 20% of all deaths are caused by cancer. And cancer, I think, is something that frightens everyone. No one wants to have cancer, and we have more and more awareness that the decisions that we make in creating the human environment often have implications for health. And so we want to be more responsible in creating buildings that are healthier. The U.S. Environmental Protection Agency tells us that we spend 90% of our time indoors, and the air quality indoors is many, many times worse on average than it is outdoors. So how crazy is that? You know, we need to be doing much, much better than that, because right outside our buildings is that air that is generally better quality than what's indoors. So let's get that fresh air into our buildings. We have the knowledge, we have the sophistication to do that. So we need to be doing a much better job. In terms of the health outcomes, as you see up here, we found that the greener, more sustainable workplaces, there are fewer absences, greater productivity, green schools, better test scores, happier children, and in hospitals they're finding better rates of recovery from surgery, for example, in the hospitals that are built to sustainable standards. Some more from the U.S. Green Building Council: perceived advantages, lower operating costs, higher building values, higher rents, greater occupancy rates, and quicker return on investment. So from a financial perspective, green building is an absolute win. It's also growing. And even so, here in the US, I expect it's maybe not too much different in Thailand. We have been in a bit of an economic downturn, shall we say, since 2008. Things are starting to look up. But you can see that even at our lowest point in our construction industry, the green building portion of the market was still growing. And then when things started to pick up, started to climb out even faster than the industry as a whole. So this is the healthiest, most vibrant part of our construction economy here, which is very exciting. It means lots of job opportunities in this field. We firmly see that this is the future. Right now, we think of sustainable building as something different and new, and yet it is going to be the new normal. Everything is moving in that direction. California tends to be at the forefront within the United States. The rest of the country eventually seems to come along with our crazy liberal ideas. And then often much of the world looks to the US and follows. And so I would say certainly from a California and a US perspective, this is a very clear trend. And this is just one. There are numerous quotes and graphs, and they all support the fact that this is the direction that we are going. It really is no longer a specialty. It's getting into the mainstream. And this is even more true for younger people, that this youth sensibility towards building sustainably this is just the right way to do it. You know, they look at my older generation and say, why did you ever do anything differently? Crazy, stupid old people. So that means we're raising them right. And some of these indicators show that the youth is thinking more progressively in this direction. So just a few examples. They are more interested in the brands that align. So for your company, your industry, to be aligned with sustainable building will be very good for business. You'll be very positively perceived by younger people. And that's going to be, they're going to be more interested in what you have to say as a result of your alignment. So these are very important factors. So in summary, I believe that creating sustainable buildings anywhere means you're creating something that is a higher quality product. You're creating a legacy for your family, for your culture, something that you can really be proud of, that is future looking, and it is truly inspiring. You know, I think that people get really excited about the green building features. I have a number of pictures to show you of projects toward the end of the presentation that are local, but I was just thinking about one. There's a school in Washington State called the Birchie School, and it was built according to the Living Building Challenge, and I'll talk about that in a moment. But the students in that school were so excited when the school opened that they were marching around chanting, living building, living building. It's like, how often do you see students get so excited about their school? You know, they might be excited about here on Halloween or some, you know, festival celebration, but about the building itself, that's really an amazing thing. So I think you have a real opportunity for leadership. Okay, so I've talked a little bit already about some of the current trends, but just to highlight a few, you're very aware of LEED, of course. LEED is still really the dominant sort of face of green building, if you will, in the United States, and as you know, globally has a real presence as well. And we are soon going to be working with LEED version 4, which shows a number of advances, and it's going to be very interesting to see how that version 4 adoption goes, because there are a lot of pretty significant changes, and I think it's going to be a ride to see how that all goes. But I think I'm really happy to see that LEED is taking significant steps, because I've personally felt that they've been a little bit slow really to kind of raise the bar over the last few years. You know, that I think early stage it truly was leadership, and then I think things were a little sleepy for a while and they kind of weren't really making too much progress. So I'm happy to see them stepping up. I don't necessarily think all the new things that are in LEED version 4 are necessarily the right way to tackle these problems, but that's how we learn, right? We try them out and then we learn how to do them better. And you probably also know then that LEED addresses all types of buildings across the life cycle. So it's a very comprehensive suite of programs, which can make life very complicated, but it's helpful. So, and some baseline requirements. Again, you're probably well aware of the certified silver, gold, platinum, that there are certain mandatory measures or prerequisites that you have to do in order to earn the rating. And above that, there are points to be earned, and in some cases a minimum number of points within the categories based on the rating. So in the world beyond LEED, what happens next? There's a lot of debate or even around the term sustainable building. Some people say, well, sustainable, that's sort of just means you're hanging steady, right? You're not really making progress. And green building, so-called sustainable building, has been criticized by many leaders in this field. Say, well, you're just doing less badly, you know. So we've generally done very badly in creating our built environment. Now we're going to do a bit less badly. Okay, we're happy with an improvement, but can we go beyond that? And so now the hope is to really move towards projects that are truly restorative or regenerative. And certainly LEED can still provide a very effective guidance in that direction. But I think it's always important to think that the rating systems are themselves, they are support, they are guidance, but they are not all that is possible. And so when we approach a sustainable building project, I think it's the best idea is to go in and say, how can we build whatever our project is, whether it's a park bench, an entire city, or an apartment building? How can we make this place better than it is now by creating this building? And the opportunities are enormous. I have a number of incredible colleagues who speak to this very eloquently, and would be another 2 hours to go into some of the finer points of their work. But one example is they were asked to assist with a development in a rural area in the Rocky Mountains in a sensitive watershed that had been severely overgrazed and had a number of ecological problems, erosion and bad soil quality and so forth. They were asked to help with the development of a housing tract. And they said, we can do that, but we want to repair this watershed. And they figured out a way to do that, create the housing and repair the watershed. So it wasn't just about making green homes in that area. It was about making the whole place a better place. And so I think that when we start with that type of ambition, we may fall short of our goals, but we rarely will exceed a goal beyond one that we set, right? So we have to be as ambitious as possible and prepare for, okay, well, maybe we don't achieve quite perfection on every project, but we want to reach on every project. I think that's important. There are, and I mentioned transparency also, so I'll talk a little bit about each of these 4 programs represented up here. Living Building Challenge. How many of you heard about this? No? Okay. So Living Building Challenge was established actually by Cascadia chapter of U.S. Green Building Council, which is in the Pacific Northwest here in Washington, Oregon, and British Columbia, Canada, are all part of the Cascadia region. They developed this as a Beyond LEED program, and the idea is the building, it's very ambitious, living building, right? It's like, okay, I'm not sure how you do that, but so there are many requirements. Instead of being like LEED, where there are a few mandatory, prerequisites and everything else is sort of optional, everything is must do in Living Building Challenge. The building must be zero net energy. It must be zero net water, meaning no added potable water other than what falls on the building in the way of rainfall. Now, some of these, that one in particular, is very, very challenging, and there are some sort of loopholes, if you will, or workarounds that recognize the constraints that exist both in nature and in our sort of civil infrastructures. So it's not as absolute as it sounds, but they try to make it pretty absolute. It has to be beautiful. It has to contribute to its neighborhood. There are a list of so-called red list materials that you may not use in a living building project and so forth. Right now, it represents a tiny, tiny market fraction as compared to LEED. But it serves a very valuable function, which is sort of redefining the far boundary of what's possible in a sustainable building, within a sort of rating system type constraint. So very ambitious, very challenging. I've worked on one Living Building Challenge project. Actually, it was started, the building design was started while Living Building Challenge was still under development. And so we didn't exactly know how the rating system would develop as the design developed. So as it turned out, we were not ultimately able to meet all of their requirements. But as they started to launch, we did begin to comply. So we did as much as possible, and it's tough. But that's a good thing. We learn from it. Net Zero Energy Building Certification is actually a subset of Living Building Challenge. And this is very recent, just in the last year or so. They kind of carved off the piece of their program that's about zero net energy and said, we're going to create a certification just for this part of it because we think it's so important to reduce carbon emissions. So, and it's a rigorous program, but because it's only about energy, it's very manageable in terms of participation in the program. Both Living Building Challenge and Net Zero require a year of operational data before the certification is given. So unlike LEED, it's not a program that was developed really to assist in marketing a building, because obviously by the time you have a year of operational data, you're probably not in the market anymore. You have occupants. It's been sold or rented or whatever. However, I think even presenting the notion that this building is pursuing Living Building Challenge or pursuing net zero will have some market attractiveness, even though it's not that kind of thing. You can't say we have it, we're pursuing it. Passive House, any of you heard of Passive House? This is another one that's taken the US by storm in the last few years. It was developed in Germany, but interestingly enough, it was based on principles developed in the United States by Amory Lovins at the Rocky Mountain Institute, who's one of our real energy pioneers. And Passive House is a program that's primarily tailored for a Northern European climate, but where a hard target of energy usage is set in terms of units of energy per square foot of building per year. A maximum energy use for heating is set, specifically for heating, and a maximum rate of air leakage is established for the building. Now, when you live in a climate where it makes sense to have open air circulation, Passive House might not be the most sensible standard, but I thought you guys should be aware of it because it's kind of the new darling in the world of sustainable building, at least in the United States and Europe. In fact, there are several jurisdictions in Europe, I think from the federal down to state, regional, and even municipal levels, that have said all our buildings will meet Passive House standards. So they're very, very efficient. They're not net zero energy because they don't necessarily have renewable energy, but they're very, very efficient, using maybe 80% to 90% less energy than typical buildings of the same size. And then the final image here is for the Health Product Declaration Collaborative. That's a US-based program. It's one of several, but which is perhaps one of the most visible initiatives that is looking to move forward this notion of product transparency. Because we do find that there are so many product manufacturers, as I showed in the graphs earlier, the sustainable building movement here is so robust, and particularly in comparison with the rest of the green building industry, that the manufacturers are kind of going, we'd like to sell to those people because they're actually buying. And so everybody wants to have a green product, right? Well, and as I cautioned you earlier, every product that claims to be green maybe is or isn't to whatever degree. And the only way we can judge is if we know what's in those products. And for so many years, we have heard over and over again, that's proprietary, that's proprietary, that's proprietary. In other words, we won't tell you, it's a secret. And our leaders in our industry have essentially said, enough of that. We've had it with, with that. You will tell us. And so there's a real movement to pressure the manufacturing industries to be more transparent about products. So we're not there yet. It's not as though all products are immediately complying, but we are starting to see things, for example, what are called EPDs, environmental product declarations, and PCRs, product category rules, for how the EPDs are made. So these are all part of this sort of ecosystem of product transparency, and something to really be on the lookout for. And my mantra is always ask, especially a composite of any type, this table is a composite. You can see there are pieces glued together. What's underneath is probably not what's on top. Who knows what's, behind this. Might be just gypsum board, or it might be some composite. What's the finish on these, the paints? What are the chemicals in the carpet? Now, something solid wood, okay, maybe I'm only worried about the coating on it. But there's so many products and materials around us that we don't know by looking at them what their constituent parts are and how those affect human health or environmental health, the biota and the ecosystems. So we need to be asking those questions. And I mentioned zero net energy. This has been a huge focus for me for the last 5 years. In fact, 5 years ago now, right this time of year, I was launched into writing a book on zero net energy homes. And I've spent a tremendous amount of my time since then educating others about it in this energy center as well as throughout the state and country and even beyond. And the goal here is, again, to get our, not just our buildings, but our communities to be more self-sustaining on an energy basis. So the energy that we require to run, we then put back into the system by having renewable energy systems on our rooftops or adjoining structures or through collaboration at a community level. So that is the basic idea. You know, we start with a building that uses a certain amount of energy. We can almost always reduce that energy substantially. Of course, it's easier if it's a new building than an existing building. We have more challenges when we're not starting from scratch. But either way, our goal is to get our energy loads down to a fraction of what a normal building would be. And we can usually reduce energy use in a new building compared to a traditional sort of one that meets building code by a good 60% or more if we really put our minds to it and make it a goal. With an existing building, it varies tremendously, but it might be 20%, 40%. We might get to 60% if we're really ambitious. One of the conversations that I often hear is, well, how much extra does it cost to design and build a zero net energy building? My answer is, it doesn't cost extra if that's part of the goal, right? Any more than the countertop in your kitchen costs extra if your goal is to build a new kitchen, right? It's like if this is an essential part of your project, it's never extra. It's just a question of, okay, I have my budget. How do I spend my budget in order to achieve my goal? And this is true of any goal, of course. But I think so often we deal with an attitude in the mainstream that would like us to sort of fix your building by adding something onto it. And so, of course, that's going to be extra. But if we are thinking about that from the beginning and it's not added on, it's woven into the fabric of the design, then it's simply part of what you accomplish, right? We build buildings with electricity. That was add-on at one time, right? And we got past that. We didn't used to build buildings with indoor plumbing, and now we do. So we're getting more sophisticated and more ambitious in what we're requiring of our buildings, and we need to be requiring of them that they be not taking more than they provide back. Now, not every building will be able to achieve zero net energy just by virtue of where it sits. It might have shading on a rooftop that doesn't allow for photovoltaics, or it might be very tall and thin and with not much roof compared to the amount of energy that needs to be provided within. So we look at it at the building scale. If that's not possible, we start to think about how might that be achieved, again, at a larger scale, community scale. Okay, so some tools and processes. Our community, our green building community in the United States now has a pretty good body of experience, right? We've been doing this for many of us 20 years now. Some pioneers who've been at it longer than I for 30 years or more. And one of the things that we've learned is that we achieve our highest performing buildings through a process of intense collaboration. It's often referred to as integrated design. Have you guys heard that term? Any of you? No? Okay. So integrated design and integrated project delivery are related, but I'll explain both and then kind of the distinction. First of all, the idea of integrated you'll see here. It's how we work, and it's also what we produce. And in terms of what we produce, the building, we achieve the highest performance through an integrated project because the systems all work together and complement one another. And we achieve that as a team because we need the different understanding, experience, background, technical disciplines, and so forth from all the parties on a project team to provide what they know in order to achieve this. And I'll give you an example. Probably about 15 years ago, one of the big ahas in integrated design occurred when the US government had funded a number of research teams through a program called Building America. Building America was a public-private partnership in which the federal government, the Department of Energy, provided seed funding to a number of energy consulting firms in order to allow them to work directly with American home builders and product manufacturers, architects, engineers, and trades. And the charge they were given was to create the next generation of American housing that is more energy and resource efficient at zero or very low incremental cost. And that sounds kind of crazy, right? But they said, you need to work together to figure this out. Well, what they figured out, because they worked together, they got all those different players around the table and kind of scratched their heads and said, how are we going to do this? Well, one thing that they learned relatively soon was, well, if we make our building enclosures tighter, so less of the air that we're heating and cooling it and using inside those buildings to make them comfortable is leaking out immediately, and we put better windows in, so better insulation. So in other words, we're doing a much better job on the building enclosure. We can reduce the size of the heating and cooling equipment substantially. The savings in the reduction in heating and cooling equipment paid for the other improvements. So that's an example of how a team working in an integrated design process was able to produce a product that was a more integrated product because they were thinking about how all those parts worked together. And so we often talk now about the building as a system or the house as a system. It's like our bodies, right? We have circulatory system and a respiratory system and a limbic system and so forth, but they don't operate independently, right? They all work together. And our buildings ideally would be the same way. Unfortunately, in our traditional design process, instead of all working together, we tend to do a handoff. So I'm the brilliant architect. I have my idea for a beautiful, spectacular sculptural building, and I hand it to Toon and say, you're the structural engineer, can you make it stand up? And he goes, oh, okay, I'll do my best. That's going to be challenging, but you do your best, and then you hand it off to Tent and say, now you're the mechanical engineer, could you make it comfortable or not so uncomfortable that anybody sues? And you say, well, okay, I'll do my best. Then you hand it off to Lee. Lee is the electrical engineer, and you say, now can you make sure that everything has power that needs it? She looks at it and says, oh boy, I got to work around, what all you clowns have done. and do my best, right? Though we call this sub-optimized design, but it's our normal way of doing things, right? Because each discipline in turn inherits the maybe less than ideal decisions that those before them have made in isolation, without their knowledge. And you could put one of those little cartoon thought bubbles behind each party's head, and it would say, if only they'd asked me, right? If they talked to me 6 months ago, I could have made this so much more efficient, right? And everyone in the building industries has experienced this. But it's taken us a while to figure out how to get past that, because it's what we're used to. It's what we think is the right way to do it. So what we now know, or those at the forefront of the sustainable building movement know, that the way we do this is we get everybody at the table like this very early and say, we need to know what all of you know, because you all have different specialties, different disciplines, and you also have a different body of experience. You've worked on different buildings than you've worked on. So, and on every building project we work on, we learn something, we observe something, even if it's not in our discipline. We noticed something that happened on that project that worked or didn't work or could have been done better. So we need to carry all that knowledge in to our team processes. Now, integrated project delivery goes beyond, because integrated design says it's all about design, right? We're going to design a wonderful building. Oh, right, but then somebody has to build it. Well, it turns out not only do we need all the designers at the table, but we need the builders at the table too, because they know stuff about making the buildings come out of the ground that as designers we don't know, or we might know theoretically. But what that represents in the reality is really important for us to know. There are cost implications and constructability implications that we would benefit from throughout the design process. So integrated project delivery says, from the beginning, we have the general contractor and the major trades also in touch with the design process and helping us develop that in an optimized way instead of a sub-optimized way, because that way we get higher performance out of every aspect of the building. So, and I love this representation of why integrated processes work. So on the left we have the normal business as usual, the sequential handoff model, and you can see that with the little sort of stars and dots, right? First the architect is hired, then some engineers, eventually the general contractor, and finally the major trades. So this is time along the x-axis, and the y-axis is common understanding. And we see in this model that common understanding among all the participants develops rather slowly as more people come on board, and then it climbs out quickly, finally only once the major trades are brought in. And it reaches a peak when we're done. Well, isn't that brilliant? We're finished. Now we all know what we were supposed to be doing in the beginning.
Maybe in the next building.
Yeah, exactly. Grand. So I love this because it says, yeah, it seems so clear when you put it this way. By contrast, in the integrated project delivery model, we hire everybody at the beginning. So our common understanding climbs out really quickly, reaches a peak early, and stays at a peak throughout the project. Now, those of you who had calculus may remember that the area under the graph represents the aggregate value. So you can see that the area under the graph here is probably 3 or 4 times what it is in the conventional model. And you think, how important, especially when we're looking for high performance. By definition, sustainable building is doing things differently, right? And so when we want to create something that's different, that's more advanced, it's absolutely critical that we have a common understanding about it among all the contributors to that project. So this really, I think, presents a very compelling picture of why we need to undertake integrated processes in order to get the results we're after. Now, there's another aspect of this that I think is also incredibly important, and that is along the y-axis, we could replace common understanding with probably 15 or 20 other values. Can you imagine what some of them might be? What else might improve if you have everybody working together early? What do you think?
The budget. The budget should
The budget?
decrease.
The budget might decrease, yeah. Yeah, because you will have fewer change orders, right? So you're probably going to save some money. What else? Other thoughts? How are people feeling?
Happy to work together.
Yes, much more harmonious working environment, right? Because they get to know each other, they're collaborating early, and they feel heard, right? Instead of, oh, if only they'd talk to me. Everybody's contributions are being valued. So it makes for a much happier team. That in turn reduces conflict, it reduces risk, reduces liability, reduces fault. Yeah, you know, finger pointing for blame, right? You're at fault. So it's very, very powerful tool. And when people are working well together too, don't they produce a better product? So really important. It's also really important to have the right people engaged in this process. I don't have a slide about this, but I have derived, my personal rule is, who are the right people for your team? There are 3 qualifications: experience, creativity, and commitment. They're all very important. Now, not every member on the team has to have all 3 of those things, but if you have to give up, say, experience, you know, maybe, you know, let's say Sam is new to this field, and so he doesn't have a lot of experience, but he might be hugely committed and enthusiastic. That's really important, right? So long as there's enough experience on the rest of the team, then that's okay. You wouldn't want everybody to not be experienced, because then that'd be a little bit risky. You want that. So very, very important process. Now, one of the things that's relatively new is, in order to engage in an integrated process where everybody is brought in early and everyone sort of has authority in the design process, ideally, responsibility is also shared contractually. Instead of, you know, in the traditional model, the architect is sort of responsible for all and, you know, carries a lot of liability, and then the engineers in turn under them. And so there's very much this process, there's a sort of separating out the contractual responsibility for risk. There are alternative contracts in place for integrated project delivery that help share risk, and ideally there might also even be one insurance carrier for all parties. And if nobody's got a different insurance carrier, probably there's not much benefit in anybody suing anybody else, right? So that removes a level of concern about this too. Did you have a question,
No.
John? Okay. Anyway, so these are several contracts that are used, just different versions, and as you can see, they all have slightly different arrangements among the different parties. But now, in most efforts that I'm aware of or have been involved in that use integrated processes, it's almost always less than perfect, right? The integrated project delivery process in my diagram or the graph where everybody starts out early, that's ideally how it would happen. In reality, you know, sometimes part of the design process is already gone when somebody says, hey, we should do this in an integrated way, or it's integrated design but not integrated project delivery. Maybe the general contractor hasn't been brought in. So there are all sorts of ways that it can be less than perfect. Maybe everybody intends to operate this way, but those contracts aren't in place. I think it's all good. I think it's all learning process. And again, if we sort of reach for the best we can do and we get some distance down that path, we're going to have better outcomes than if we don't make an effort to adopt an integrated process. So this is not an all or nothing, you know, succeed or fail kind of thing. It's a learning process. And every project that I'm involved in, we generally try to embrace an integrated process a little bit farther. So it's always evolving. Now, working with people in that way, as you can imagine, has in some ways more challenges to it. It's like, oh, do we have to all be in the same room all the time? But I work down the street and you work across the bay and somebody else works in Southern California. How does that work? Well, we do a lot of our work in virtual meetings and we stay in touch via a lot of cloud applications. So those platforms are really powerful tools for us. These are just a handful of things that can be useful. Personally, I use Basecamp for most of my projects. It allows a central file sharing repository. There's also team communications. Emails can be routed through it and sort of captured via a filter, so that, and you can categorize them so it's easier to find threads. And there are a few other features. Central Desktop is similar. It's a little bit more sophisticated. It's better, for example, when somebody checks out a file, you're aware that someone has checked it out, so you don't check it out at the same time and have two versions that are being changed and then oops, right? So with Basecamp, you have to actually notify, say, hey, I'm checking out this file, and don't do anything with it till I send it back. And Google Groups is the most basic, right, of document sharing. And probably you guys are also familiar with lots of utilities out there like Dropbox and Box, and I mean there's a million of them. But I personally really like the collaboration platforms that are more fully featured because they allow you to work sort of in a project environment as opposed to an application environment. You know, I think it's very helpful. Okay, just a few sustainable buildings in San Francisco. Now, San Francisco has a pretty robust green building ordinance, a regulation that has required for quite a few years that a lot of our buildings be LEED certified. So in a sense, it would be hard for you to find a newer building in San Francisco that is not green, or even an older building. For example, the building where the Lifelong Education Institute is headquartered is a few blocks from here. And what's the date of the building?
Before the 1906 quake. It survived the 1906 quake.
So it's an old building. It's the Mills Building, so early 20th century. And it is a LEED Gold building, I believe, certified under the existing building operations and maintenance system. So that's not so obvious. You would see the plaque if you go in the lobby, but I just thought I'd highlight just a handful of maybe some of our sexier green buildings here. So the San Francisco Public Utilities Commission headquarters, which is up Market Street and into our Civic Center areas, relatively new. It's a real sort of poster child. This structure emerging from the side actually houses wind turbines. So the wind passes through this abutment, which is an art installation, hits the wind turbines and passes on. Now, these are vertically mounted wind turbines, I believe, which aren't necessarily the most effective, but it's, again, as much sort of sculpture and statement about energy use, renewable energy use, as it is functional. It does provide some energy for the building. There's also a black water treatment system, part of which is visible, not in this slide, but at street level. So if you were to go visit this one, you would be able to see part of that system. They offer tours there every Friday at noon, but you can go in any time, on your own and just look around the lobby, and there's signage and things. It's a pretty cool building. The San Francisco Federal Building, it's very interesting, and it has a lot of features that are designed for sort of solar shading, but anyway, interesting, and also LEED rated. This one's much more fun, the Exploratorium, which is a science museum. And if you go all the way down Market Street to the bay at the Ferry Building and then go along the waterfront to the left, you won't go terribly far before you get to the Exploratorium. This is, it does not yet have a full year of operational data, but it is on target to be zero net energy. And if so, it will be the largest zero net energy facility in the country. And it's just a heck of a lot of fun. It's experiential. It's for children of all ages, if you know what I mean. One of my favorite things in the new museum is all the way at the back and then upstairs, there's a series of flat screen monitors about this big, and there must be about a dozen of them in a row. And they're set up, it's an art piece that's waves breaking on the beach, and it's the same image on every monitor, but the timing is slightly different, so it creates the sensation of a whole front. It's just beautiful, and then it changes, and anyway, stunning. There's so many things to do in here. I highly recommend a field trip if you have time. Also here, the California Academy of Sciences. This is in our Golden Gate Park, which is sort of west, slightly southwest of here on the other side of the city. Golden Gate Park is a beautiful urban park. It was designed by the same designer as the Central Park in New York, I believe. It was basically crafted out of sand dunes, so it's a bit of a miracle of landscape architecture. And in the park we have two major museums, the DeYoung Art Museum and this California Academy of Sciences. And you can see on the top of this there is a very extensive living roof, and you can go up and you can visit the roof.
Side? In the roof.
It's sod. Yeah, well, it's actually a blend of plants. They're mostly native plants, so many of them flowering. So up close it's really quite lovely. So, and there are a number of habitats. The part on the right that has all the little round skylights is part of a tropical sort of spherical habitat rainforest that's really beautiful. And then in the middle there's kind of an atrium cafe, and then the one on the left is a planetarium. There's also an aquarium in there. And there's even a portion of the building that's preserved from 2 renovations back. So a much older version of the building. There's a natural history component with some dinosaurs, and anyway, lots of really great stuff. Folsom Door Apartments, not far from here, a little bit farther down Folsom Street, which is 1 street over from here. This is an affordable housing complex that was built probably 10 years ago, met the LEED standard. It was probably the first apartment building in the city to meet the LEED standard. Very attractive interiors, and it's held up really well. And then these are Nove condominiums. This is in the Mission District here in San Francisco, a little bit farther to south. And this is a luxury condominium, so the other end of the housing, well, not quite the other end. I've worked on some really crazy, far luxury homes, but these are new ones. This is actually, of all these projects, this is the only one I have worked on. This is a LEED Platinum building, and there are, let's see, 9 units in this building, 2 in each. There are 3 buildings here. They're all 0 lot line, stacked flats, and then there's a small strip of garden behind, and then 3 more units behind on an alley. So it was very clever use of urban space. Okay, and then just a few minutes about our Sustainable Building Advisor program, which we offer in a number of locations, including one other country so far, Canada, and I thought this might conceivably be of interest to you as you carry the sustainable building message back to Thailand. So our program really was designed to provide not only an education, but to craft a community or a network for people who participate in the program so that they become immediately a part of the green building community fabric in the place where they take the course, through working closely with their fellow students and also through a network of guest instructors. And you'll see our curriculum outline looks a lot like, say, the LEED rating system. We touch on the same types of issues. In fact, the LEED rating system is grounded very much in the same knowledge base and the same philosophies as the Sustainable Building Advisor program. And this program has been around for 15 years. It actually predates the LEED accredited professional, was birthed almost around the same time as LEED itself. So that's why it's no coincidence that we cover the same types of topics. So it is designed for working adults. We have a live classroom component. Right now that consists of a half-day Friday afternoon and then full-day Saturday, typically on alternating weekends, although we have a compressed format in summers. So it's designed to enable people to get through the program with as little as possible time out of their normal work schedule. And so they would miss 7 half-day Fridays in a 3-month period. And we have a whole variety of activities, hands-on activities, many of which take place here at the Energy Center. Besides what you saw, there's a lot of other stuff here, and so a number of hands-on things. We do a lot of field trips to some of the buildings that we've shown you. There are readings and there are assignments, and all of the assignments build toward a team project. All of this is taught by experienced practitioners. So we have a head instructor who serves to sort of nurture the whole program, but then we also have guest instructors, usually 15 to 20 throughout the course of a term, because no one individual is deeply expert on all of these areas of the curriculum. So we bring in someone who really knows, indoor plumbing fixture conservation. We know someone who really understands efficient mechanical systems, for example, and all that. So we have a great network of very loyal graduates, around 1,500 or so at this point, and they all have really nice things to say about how helpful it's been for them in getting jobs. And a critical piece of this, as I mentioned, is the team project. So every class, we might have about this number of people in a class. They would typically break up into maybe 3 teams, work together throughout the term on a team that they pick together and they develop together. And it's usually a real project. So, last term, for example, we had one woman who works for an affordable housing developer here in our Chinatown, and they own many, many older buildings scattered throughout Chinatown. And she and 2 other team members decided that they were going to develop a plan for retrofitting 3 of their buildings and deciding what would be the strategic, sort of high value retrofit measures to take. That was one of the projects, and there were a couple of others. So every time it's a project that's developed by the students for to support their own learning objectives. At the end, there's an exam, a qualifying exam, and they earn a certificate. So they are a certified sustainable building advisor, which is a nice credential to carry out in the work world. As I mentioned, we have, it's more certified than 1,300. I think we're 1,400 plus, creeping up to 1,500 now. Certified sustainable building advisors. We have folks who come from a ton of different backgrounds and move on. It's very common for them to go on to work. Even some have started their own businesses with people they met in the program, or have gotten jobs from instructors in the program. So they're very successful in going out into a huge range of industries and taking on sustainable building roles. And there's a list of some of those industries. It's not exhaustive, but you can see all of this is on our website with more detail. So thank you very much.